All right, in this video here, we're going to talk about evaluating trigonometric functions using the unit circle. There's really two parts to it, and I did some videos before about the unit circle itself and finding terminal points. That's the biggest part of this, is being able to locate the terminal point for the t value or your input value to your trig function. So the first three signs, or the first three steps of this are finding that terminal point, and then the last part is actually bringing in the definition of the trigonometric function. So first thing, locate the quadrant of your terminal point. There's four quadrants. You have to figure out for this t value, when I go around the unit circle, which quadrant do I end up in? All right, so that's the first thing, is locate your quadrant. Then you want to find your coordinates of the corresponding terminal point in quadrant 1. And for that, you can use the trig hand, which I've done a couple of videos where I use trig hand, and I'll use it again in this video when we do some examples. So you figure out, well, if it's a pi over 6 number, I figure out the terminal point for pi over 6 in the first quadrant. And then step 3 here, adjust the positive and negative signs of that terminal point to fit whatever quadrant you're in, right? If it's, pi over 6 is root 3 over 2 comma 1/2, but if I'm in quadrant 3, well, in quadrant 3, I have to make both the x and the y's negative, so it would be negative root 3 over 2 comma negative 1/2, and then that gives me my terminal point for the t value, for the input value to my trig function. Right, so those first three steps are just figuring out the terminal point. Like I said, I've done videos about finding terminal points, so if you haven't seen those yet, you might want to watch those, because that's really the biggest part of being able to do this, is being able to find that terminal point and being able to find it quickly enough that you don't waste so much time just trying to evaluate one single trig function. Right, so you got to find the terminal point, and then the last part here, you have to take those x and y coordinates for your terminal point, and then also put that together with the definition of the trig function you're looking for to evaluate the function properly. Right? So if it's the sine function, I need to take the y coordinate of my terminal point. If it's the tangent function, I need to do the y coordinate over the x coordinate. Right? So I did another video on the definitions of the 6 trig functions. So you need to know those 6 definitions of those 6 functions in terms of the terminal points, the x's and the y's, and you need to be able to find the terminal point on the unit circle in order to evaluate a trig function, right? So there's the two different parts of it that are both equally important in order to be able to evaluate trig functions, right? So those are our basic steps. I'm going to pause the recording here and erase these steps, and then for the rest of this video, I'm just going to do as many examples as we have time for of evaluating trig functions following all these different steps. All right, first example we're going to look at cosine of 2 pi over 3. Right, so for now, forget about the cosine, forget about what trig function this is. That's like the last step, is looking at what that trig function actually is. But we need to concentrate on this 2 pi over 3 and figure out what is the terminal point for 2 pi over 3. All right, so let me real quick draw myself a little unit circle. And when you're doing these problems, you're going to be drawing a lot of unit circles. So just somewhere in your notes or in the work that you're doing for homework problems, just draw a little unit circle there, just to kind of show the work that you're doing to figure this out. All right, so got my unit circle. My t value is 2 pi over 3. Remember, the t value refers to how far you're traveling around the circumference of the unit circle. So we got to figure out in which quadrant are we going to end up in. If I start here, we're always starting on that positive x-axis, and then since it's a positive number, I start moving upwards here, going counterclockwise, and then when I travel a distance of 2 pi over 3 around the circumference, where do I end up? Which quadrant am I actually in? Well, 2 pi over 3, think about that as 2/3 of pi. All right, remember, pi is way over here on the negative x-axis, right? Halfway around the unit circle, you travel a distance of pi, right? The full circumference of the unit circle is 2 pi, right? So half of that would be 1 pi, which is pi, right? Well, 2/3 of pi, that's less than 1 pi, right? Up here is 1/2 pi, or pi over 2, right? Halfway around is pi. A quarter of the way around is half of that, is pi over 2. Now 2/3, that's less than 1 whole, but 2/3 is bigger than 1/2, right? So 2/3 pi, or 2 pi over 3, is going to be somewhere over here in the second quadrant. Right, so there's where my terminal point is going to be for 2 pi over 3. Right? Again, think of it as, and I did some videos about terminal points where we did a similar thing, so I'm not going to spend as much time on it here. But this is an important thing to be able to do in order to evaluate a trig function. Right? So 2 pi over 3 in which quadrant is that going to be? Now, one thing about doing trigonometry is if you do enough of it, if you see enough examples, if you work through enough examples and homework problems and stuff, there's only really 3 points in each quadrant that we use to do this type of thing. So that's what 3 times 4 is 12. So there's 12 points plus the ones on the x and y axis. So that's basically 16 points that we use over and over again on the unit circle. So once you do a bunch of problems, there's only 16 numbers there. So you start to see the same numbers over and over and over again, and you'll get to a point where, all right, I've done 2 pi a whole bunch of times. I know that 2 pi is in quadrant 2 because I've just done it so much. Right? When you're first learning it, this is how you can figure it out. Compare that fraction 2/3 to 1 pi to 1/2. Well, it's in between 1 and 1/2, so we're in quadrant 2. But I mean, in some of the other videos that I've done, and I've done maybe like 6 or 7 so far on the unit circle and trigonometry, I've already used that number 2 pi at least in 2 or 3 of those other videos. So it starts coming up over and over again, and you start to just, whether you want to or not, you just remember that 2 pi over 3 is in the second quadrant. It just happens. All right. So if this stuff is kind of mysterious to you at first, you'll get there to the point where you start to just know how it works. All right. You just got to keep working on it. All right. So 2 pi over 3 is in the second quadrant. All right, so I got that. Now I got to find the corresponding point in the first quadrant. Right, that point gets reflected over to the first quadrant. Well, that's going to be at pi over 3. And like I said in some of those other videos I did about finding terminal points, just whatever the denominator is of this fraction, forget the number up there, the 2. Pi over 3, that's going to give me my number in the first quadrant that I'm looking for. Right, so if this was 2 pi over 6, this is going to be a pi over 6 number. Although 2 pi over 6 is pi over 3, so that was a bad example. But whatever the denominator is here, that's giving me that number in that first quadrant that I need to be concerned with. All right, so 2 pi over 3, I'm comparing that to pi over 3. All right, so I go to my trig hand. Again, I did a video using the trig hand, so if you haven't seen that yet, you might want to check that out. It's 0, pi over 6, pi over 4, pi over 3, and then pi over 2. Right, so whichever one I'm looking for, in this case pi over 3, I put down that finger, which in this case for pi over 3 is the index finger. The number of fingers above gives me my x-coordinate. Remember, there's always a 2 in the palm, so it's root 1 over 2, but the square root of 1 just equals 1. Right, so my x-coordinate is going to be 1 over 2, or 1/2, and then the number of fingers below the one that I put down gives me my y-coordinate. So there's 1, 2, 3 fingers below that, so my y-coordinate is root 3 over 2. Right? X is above, Y is below, 1 over 2, root 3 over 2. Those are my terminal point, or that's my terminal point for pi over 3. All right, so that's pi over 3, but I'm interested in 2 pi over 3. Right, so I found my corresponding point in the first quadrant. Now I just need to change the signs of this to match up what the point should be when I'm in the second quadrant. Right, remember, the unit circle is incredibly symmetrical. Right, so if I take a pi over 3 number here and reflect it over into the second quadrant, the x and y coordinates are going to be the same except for the positive and negative signs. And if I'm in quadrant 2, I have a negative x coordinate and a positive y coordinate. Right? So from the origin I move left, so that's a negative x, and then I move up, so that's a positive y. So it's these same numbers, but it's the negative x. So it's going to be negative 1/2, comma, positive root 3 over 2. Right? Because in quadrant 2, my x is negative and my y is positive for any point that's in the second quadrant. Negative x, positive y. All right, so there's my terminal point for 2 pi over 3. Right? And again, that's, if you watch the other videos I did, that's stuff that we've done before, finding that terminal point. Now we're ready to actually evaluate our trigonometric function. So this of the 4 steps I had before, we just did the first 3 steps, right? We found the quadrant, 2 pi over 3 was in quadrant 2. We found the terminal point for the one in the first quadrant, the pi over 3, using the trig hand. And then I reflected that, making the x negative because we were in quadrant 2. So I've got my terminal point for 2 pi over 3. Now I look at my trig function. It's the cosine function. And now I need to remember what's the definition of cosine. Right, and I just did a video where I talked about the definition of all 6 of the trig functions. So another thing you have to know in order to be able to do this. But cosine, if you recall, is the x-coordinate of your terminal point. Well, my x-coordinate is negative 1/2, so cosine of 2 pi over 3 is negative 1/2. And I've just evaluated that trig function. Cosine of 2 pi over 3 is negative 1/2. Right, the cosine, the output for the cosine function is the x-coordinate of your terminal point for this t value, this 2 pi over 3 that's in here. Right? So the bulk of the work of evaluating a trig function is finding the terminal point on the unit circle. Right? So the quicker you're able to do that, find the quadrant, use your trig hand to get this, change the signs, and then it's just knowing that cosine is the x, so I need to take the x-coordinate here, and then that's my answer. All right, so that's the bulk. When you're evaluating trig functions, it's not a lot of like calculations and things like that. It's a lot of like a thought process, right? All right, 2 pi over 3. Which quadrant am I in? Let me think about this. Let me compare the 2/3 fraction to the 1 and the 1/2, right? What's the 1 in this end? Let me use my trig hand to do this. Again, you're not calculating things, you're just thinking about them. All right, I can get my 1/2 root 3 over 2. Now I'm in quadrant 2, so I need to make my x negative. And again, it's not calculations, it's not doing a lot of computations. It's just thinking your way through these steps, and then, okay, cosine is my x, that's my answer. All right, so that's how you go through evaluating a trig function. It all comes from that terminal point on the unit circle, and then just knowing the definition. All right, I'm going to pause the recording again, put up another example where we'll evaluate another trig function. For this example here, we've got tangent of negative pi over 3, and I'll try to do this one a little bit quicker than that last one with less explanations and more just going ahead and doing it. I don't want you to think that every time you evaluate a trig function, it's going to take you 10 minutes to do every single problem. If you get proficient at it, you can do it pretty quickly. All right, let me shut up and actually do this now. All right, so tangent of negative pi over 3. Find my quadrant. All right, so negative pi over 3, remember, for negative t values, we go in this direction. We start at the positive x-axis, we go down to the 4th quadrant. Well, pi over 3 is just up here. All right, this is positive pi over 3, so I'm going that same distance, but just in the opposite direction. So if I go negative pi over 3, I just end up that same distance down here in the 4th quadrant. So here's going to be the terminal point for negative pi over 3, which is a reflection of the point at pi over 3 down into the 4th quadrant. Right, positive pi over 3, this distance that way. Negative is the same distance, just going in the other direction. All right, so there's my terminal point for negative pi over 3. Now I need the coordinates of that terminal point. So I go back to the 1st quadrant, pi over 3. I go to my trig hand. Pi over 3 is my index finger. Right, I have 1 above, so that's my x is 1/2. I have 3 below, so my y is root 3 over 2. All right, so 1/2 root 3 over 2. And then I reflect that down into the 4th quadrant. So when I'm in the 4th quadrant, my x is going to stay positive, but my y is going to become negative. Right? Because any point in the 4th quadrant is going to have a positive x-coordinate, but a negative y-coordinate. So I move to the right, so that's a positive x, but I move down, so it's a negative y. So there's my terminal point for negative root 3 over 2. All right, so find the quadrant, compare it to the one, the corresponding, in this case, pi over 3, because my denominator is 3. Get that terminal point in the 1st quadrant, reflect it, change the signs if you need to match the quadrant that you're in, and then I go to my actual trig function here, the tangent function. So what's the definition of the tangent function? Well, tangent is the y-coordinate over the x-coordinate. So tangent of negative pi over 3 is the y, negative root 3 over 2, over the x, which is 1/2. Right, so once I get my terminal point, I go to the definition of my trig function, and I just plug those numbers in. Y is negative root 3 over 2, x is 1/2, and then I have to simplify my answer. Don't leave your answers like this with compound fractions, like fractions within fractions. If you have compound fractions, you need to simplify them. If you end up with square roots and denominators, you have to rationalize your denominators. So make sure you do those simplifying things. Don't just leave your answers all sloppy like this up here. All right, so negative root 3 over 2 over 1/2. Since all of my fractions when I'm doing these terminal points are over 2, anytime this happens, those 2's or those halves are going to cancel out. So it's not hard to simplify this. The 2's just cancel out. I get negative square root of 3 over 1, and anything over 1 I don't need to write as a fraction. I just have negative square root of 3. All right, so tangent of negative pi over 3 equals negative square root of 3. All right, so again, I take my t value, my input value to my function, locate the quadrant that's going to be in this case quadrant 4, compare it to the corresponding number in the 1st quadrant, use the trig hand if you need to get the terminal point there, change the signs if necessary. In this case I had to change the y to negative, x stayed positive. Then go to my trig function, the definition of tangent, y over x, put the y coordinate over the x coordinate, simplify it, I've got my answer. All right, so that's how we can evaluate trigonometric functions using the unit circle and the terminal points.